Can you see my screen?
Yes.
All right. So I hope everyone has read through this document, but do you want me to go over this document quickly, or do you already have some questions that we can answer? How do we want to proceed?
I guess the plan was that you go over it,
Okay.
not in full detail, because then we don't
All
have
right.
the time, but
Okay.
it's the first meeting. So that was the plan.
Okay. Fine. So motivation of this meeting is to introduce you to the POC that we did last year, and we have. So in our team, we manage MCM and a fork of cluster autoscaler. So we have been managing a fork of cluster autoscaler for several years now, and we have had several problems with especially the interplay of CA and MCM together, as we have a lot of overlapping functionalities between CA and MCM as two different actors. And that is one part of the problems. The other problems that comes from the fact that CA itself has several issues that we have identified, unearthed over the several years that we have been dealing with CA. And over a period of time, we have found ourselves changing more and more of core CA code. And these are actually quite critical functionalities from, these are functionalities in the main line of code flow for CA. And therefore, making these contributions upstreams are simply not going to be accepted, because MCM is just one of these providers, and there are multiple other providers which are already in tree in the cluster autoscaler repository. And MCM, unfortunately, is not in tree, and therefore, this is one of the initial primary reasons because of which we had to actually have our own fork. So this is another set of problems that we will talk about briefly, and because what we have done is we have actually segregated these set of problems into different segments, and each one, trying to detail out in some form of fashion problems that we have identified. This is not a complete list, obviously. There are a lot of issues that we have faced over a period of time. There are a lot of bandages that we have put just to make these two actors work together and not cause problems with for each other. So let's go over the first set of problems, which is the overlapping actors. So we have, as you know, machine control manager, which handles the lifecycle management of all the machines and also the upgrading of all the machines. And then we have a cluster autoscaler, which essentially makes recommendations with respect to scale up. It creates a scale up plan based on what are the pending pods and then what are the nodes that are required. And it works under the constraints defined on the node group, which is the autoscaler, the type that is introduced by the autoscaler to define. So node group is nothing but a combination of instance type and zone. And then when we create a worker pool, then we essentially create these node groups, and then these node groups are statically created and given as a CLI argument to the cluster autoscaler, and then it starts. Cluster autoscaler also provides a refresh method to refresh these as and when if it changes, but in Gardener we don't use it that way. So now we have timeouts that are defined at the machine controller manager level and also at the CA level, and these are kind of overlapping timeouts, and one needs to really know how to properly configure these. And if you don't configure these properly, then you end up into problems. And we have highlighted one of the issues where these problems are there, and then we also have a recommendation which is part of the FAQ for machine controller manager. One is machine creation timeout, max node provision is one such combination. Another is machine trace timeout and max traceable termination seconds. This is another one which has an overlap. So these are just two examples of an overlap. One very peculiar thing about CA is that so when it tries to remove a node, it adds an annotation, adds taint, which is to be deleted by cluster autoscaler on the node. And this taint, obviously, this causes no additional workload to now be provisioned, scheduled onto this particular node. what is peculiar is that if CA crashes, and trust me, it does crash quite a lot of times in live landscapes and kind of landscapes, we have seen this, then it magically blindly removes the stain from all the nodes, which means it tries to reset the state it starts from scratch. Now, the problem is that MCM, when this to be deleted taint, to be deleted by cluster autoscaler taint is added, the request is also sent to MCM that I wish to remove this node. So MCM takes that request, and while it is trying to process that request, cluster scaler autoscaler goes down, comes back up, and then magically removes the taint. This causes any workload that is now pending and wants a node to get scheduled to, it gets scheduled onto this particular node, while MCM is probably trying to remove this node. There can be a delay because of which the workload can get scheduled, and now when we try to remove this node, then there will be a downtime for these workloads. We do not know. We tried to trace the history of why this has been introduced in cluster autoscaler, but we couldn't find it. Now, the cluster autoscaler triggers the drain of nodes, and this is one of the functional overlaps that we wanted to highlight. So draining of node is something which typically it does for nodes which are underutilized, and since MCM in the deletion flow of MCM does the draining of the nodes prior to termination of this VM. There is an overlap of functionality between cluster autoscaler and MCM. Now, and as we also highlighted that these operations are asynchronously executed by MCM, so we have probably touched upon this point, so we'll probably go to the next section. CA has inherent design flaws, and we have noticed quite a number of problems with these. So one of these problems that we have noticed is that, and this we recently fixed actually, there are a lot of go routines that CA starts, and these go routines actually try to call cloud provider implementation methods. So there's a cloud provider interface which every cloud provider cloud provider has to implement. So AWS, Azure, and Cluster API and many others have their in-free implementation, and MCM has in its fork of cluster autoscaler. So please feel free to interrupt me if there are any questions.
I think we can increase the zoom level a little bit, just a little bit, yeah.
Is it better?
Yeah, thanks. Yeah.
All right. So one such issue we noticed, because of which what happens is that because of the asynchronous nature of the communication between MCM and CA can make a request, reduce replicas on the machine deployment, and then MCM takes over the responsibility of processing that request of maybe scaling down, scaling in a specific worker, machine deployment. While this is happening, it's possible that since it's asynchronous, so it goes and starts another loop of reconciliation. So every loop of reconciliation has a 10-second default gap between the two. And then it's possible that MCM has not yet taken an action, and CA now makes a duplicate call. And there are multiple go routines in the code which actually call the same method, from different places and different code paths. And this is not one, but there are multiple methods. So increment nodes, delete a node, specific node. So there are multiple such methods in the cloud provider which actually are called via these go routines. And this actually, yeah, go ahead.
Yeah, just to explain that why that's a problem. We have seen CA run once loop, which is unfortunately not really run once. It's more like run concurrent now. Call increase node group size on the same node group with different values. Value 1 in the previous run and value 2 in the second one, and both these the first one is still going on, in the sense it's not finished. It's so.
Yes, exactly. So this causes a problem, and now we had to very recently fix this problem by making another bandage to the MCM code, so that we can actually handle this this concurrent calling of these methods with potentially different values. Then you have, over a period of time, CA has become complex. Now, with at least with 132.0 release, you have now 113 CLI flags. 5 of such flags are, as we know, are cloud provider specific flags. because you have all in-tree implementations of cloud, majority of the cloud providers except MCM in there. Therefore, it's quite natural that you have cloud provider specific flags, which and most of these flags we don't use. The only ones that we expose from within the Shoot API is 15 of these CLI flags are then also introduced as part of Shoot API. So it's very hard for any consumer to actually fine tune these flags, because a good amount of knowledge is really required to actually properly configure these knobs, so to say. Now, the current design and complexity of the code base has made it harder to actually have larger refactorings done. And if you see the 5394 issue, it was actually proposed from the community. There was a proposal from the community itself to actually split it into provider agnostic and provider specific parts. And it was further proposed to actually make it into a pluggable library. This was actually discussed in the autoscaler script group, but SIG group, and then it was eventually rejected because the code that is there in its current shape and form, changing and implementing this and making this change means that there is going to be a very high maintenance and possibly because it's a very huge change, and this possibly introduces regressions, and they were not very comfortable of making this change. So any bigger change is something that they are not ready to take up at this point of time. And if you look at the code base, it does not follow any Kubernetes best practices which have evolved over a period of time. I mean, if you see Gartner, we have evolved over a period of time. We now constantly change our code base and are in line with the best practices that the community recommends. But if you see cluster-autoscaler, we don't see any client go work queues being used or controller runtime, which highlights its age. It has been observed that CA has several fundamental issues. So if you see this issue list, you have any issue that has more than a few files changing and a slightly bigger impact on the code base. They all are not worked upon, not accepted. People have raised PRs, people have raised issues, and they are just lying rotten, and they eventually get closed. There are just 3 of these issues that we have highlighted, but there are many such issues. And these are valid issues. We also checked it. We also verified these 3 issues by replaying this on the virtual cluster autoscaler that we actually created. We'll explain that in the later part of the document, what we did, and we were able to reproduce these problems. So these are the problems that we have ourselves verified. Now, CA has another problem where it actually makes a decision to scale out and look for unscheduled reports. It looks for existing nodes. So this was another issue that we have encountered very recently. It's 495498 as a live issue, and so the customer applied node level taints to achieve tenant isolation. So it's a taint that it applies to certain set of nodes out of many nodes. What CA does is when it starts a new node, when it tries to scale up that particular node group, it picks up any node to get the node template, so to say, from which to create this particular node. If this node happens to be the node on which the customer added that taint, then it also applies this taint to this node, which it should not, because if you do a scale from 0 case, then you have a node template that it looks at, and then it tries to create the node from the node template. But if it is not a scale from 0 case, and if there's a scale up done, and there are existing nodes, then it takes randomly any node and then uses that node as a template to create a new node. And this creates a problem. Now, this is again another point, is again a design flaw. So it doesn't disambiguate between the scaling recommendation and applying that recommendation. I think I have a slightly older version.
One second. I think you have to refresh.
One second. Now we have a new version. So CA doesn't disambiguate between, in CA terminology, it's called scaling plan. So I have been using scale in and scale out, which is the correct terminology, in spite of CA using a very incorrect terminology of scale down and scale up. This is typically vertically. up and down, but this is horizontally, and it actually does horizontal. So there is slight digression from the CA terminology in that case. But in this case, we changed the terminology and called it scaling plan. That is what CA calls it. So CA doesn't really have a difference, or it doesn't disambiguate between a scaling plan and applying that plan. They are intermixed together. This doesn't provide any choice for the cloud provider to 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 look at this plan and selectively apply that plan. That is not the case, and that feature is completely missing, which causes a lot of friction between these two actors: an actor which creates the scaling plan and the actor which tries to apply the scaling plan. And one classic case is when we do a rolling update, then MCM actually tries to uh, forcefully disable scale downs during the rolling update because it interferes with the process of the scaling update. And this had to be done in the cloud provider implementation for MCM because CA doesn't really care about what the processor of the scaling plan is actually doing or not doing. So this is one of the design flaws that we found. Now, there's also a big problem with respect to an impedance mismatch between a CA and a kube scheduler, and we have found several issues, only highlighting one of the top 3 issues that we have found out.
And you can say this is actually over and above the various design flaws and problematic issues. This is one of the you can say one of the prime motivators of making a new scaling advisor, recommender, or planner.
So CA typically, so there are multiple phases of kube scheduler, and CA only uses the filter stage of the kube scheduler, and kube scheduler exposes certain APIs, Golang APIs. CA uses only the ones which are in the filter plugins. As a consequence, if you have workloads that have defined prefer during scheduling soft constraints, so to say, they are never honored. And this is also documented in the official FAQ of CA. This is also explained if you go down in the appendix section, this is a very nice article which also in detail explains why CA will not provide any support for soft constraints. Okay, going back. So this is one of the this is one of the problems because of which it does not make an optimal choice of node groups to be scaled. There was a canary issue 4276, which where CA differed from this kube scheduler. So the kube scheduler said that I cannot schedule certain pods. However, CA saw that they are pending pods, tried to run only the filter plugins of the by calling kube scheduler API or filter plugins, and found out that it can schedule these pods. As a consequence, it never bothered to scale up any node. Kube scheduler will not schedule it. CA will not scale up, scale out any node. As a consequence, these pods are pending forever. So there are differences that have happened between the decisions that are taken by the kube scheduler and the decisions that are taken by cluster-autoscaler. Since 1.18, kube scheduler provides support for cluster-wide default pod topology split constraints. And I have provided a link here. This obviously is not going to work because this is part of scoring phase of the scheduler, kube scheduler. And CA, since it only does use the API for filtering phase, it does not support it and will not support it. In general, if the kube scheduler evolves, and which it will, and it is already doing. For example, in recent times, there is going to be there's a lot of work going on in the DRF phase where dynamic resource allocation, specifically, a lot of work is going on for sharing of GPUs, cross-node, defining cross-node resources to allow multiple CUDA workloads to actually write to each other's memory across GPUs, across nodes. All this is something that is coming into the kube scheduler. And plugins have been introduced at different phases of the kube scheduler. And all with every such evolution, the difference of opinion between CA and scheduler will only be larger. Then the next section talks about inefficient scaling of node groups. Tarun, you want to take it, or should I continue? You are muted.
So yeah, so the CA code is in its controller root, it's hard coded to prioritize scale out over scale in. So first, you do all the logic to determine whether you need to scale out, and then you perform the scale out, and only then you determine whether you need to scale in, and then issue a call to scale in. What can happen is that scale in can be deferred quite to a very long extent, and this causes resource exhausted problems, especially when you're doing some rolling update. And so some consumers like HANA who have limited capacity, they need to prioritize scale in first over scale out. And they have a bunch of hacks implemented because of the behavior of the CA. And yeah, I mean, this one of these hacks is to set scale down unneeded time to a very aggressive value of 0 while loading update is going on, only to reset post once the update is completed. And this causes flapping, node flapping. And there also is a unfortunate interaction with the startup trains, okay, uh, uh, added for node critical components, thus making these nodes unavailable due to scheduling of pods.
They,
In my opinion,
they,
go ahead. Yeah.
there was a PR and an issue raised on Gartner because this was increasingly becoming a problem. Unfortunately, we had to close down that PR as something that not essentially it was implementing a webhook which tries to force the consumers to have a minimum value of unneeded time as 1 minute and not 0. This was opposed by HANA colleagues, and we had to close that PR. So it was not really pushed, merged in. Go ahead.
Yes. Then secondly, when selecting node groups to scale, it employs a simplistic node scoring by computing wasted resources. Madhav already mentioned this, so that only CPU and memory are used to compute resource wastage. GPUs and other resources are not considered. CPU and memory are treated with the same weightage, even though their costs are not proportional. The price of CPU and the price of memory, for example, are not equivalent across instance types, zones, and regions. Generation of CPU also significantly changes the cost of the instance. So effectively, it can scale up a node group, which is much more expensive than the node group it could scale to match the workload. Then, yes, special requirements like accelerated networking is not taken into account. And then most importantly, it prefers to max out a single node group at a time. It considers only one node group at a time. This results in imbalance in the distribution of nodes across availability zones. So this
I mean,
is,
we have, I think, Vedran, you can add probably
yeah,
I have linked to
yeah,
your Slack.
yeah. Vedran
uh,
mentioned this issue even better, actually. So explained it
so,
quite well in the Slack
yeah,
convo.
because and we have not, this is just one example of what Vedran faced, but we have seen quite a lot of imbalance amongst different zones.
Interestingly, Carpenter also mentions this as one of their advantages over the CS, so zone balancing. So then, then of course, so this was already sort of covered in a way that CA doesn't take into account things like rolling updates because we have the planning, scaling plan and scaling execution are coupled together, and CA doesn't know anything about rolling updates. So today we do disable scaling during rolling updates. We also, unfortunately, in our fork, comment out some code in the CA1 loop, run once loop, which tends to adjust the node group size due to utilization. And that a major problem, headache, if you're trying to do rolling update. That I think is covered in another point in the bottom. I'm not sure whether we have missed that, but there's a bug in the CA reported by both the cluster API as well as us, where when they're adjusting the size, node group size due to utilization, they don't tell you explicitly which nodes to scale down. With the results, the cloud provider can take some random nodes to scale down. So cloud provider cannot guess that. So the cluster API folks also mentioned this issue as well in a ticket. Then this is also one problem, as Madhav pointed out, because of this first fit decreasing bin packing algorithm, it can over provision nodes. So C tends to overscale, and then in the next loop, it then decreases the node group size. So you have a node flip flap, which is quite visible because some of the HANA colleagues always point out, why is this flapping? So why does it first increase in a group size and then decrease it? Because there's a transient increase in the number of potential underutilized nodes. Okay, so And unless you have your scale down time aggressively configured, this nodes will be there for more amount of time than what is needed. There's also a challenge with respect to the performance. This is not as expected in the CA performance guidelines. So we saw that with an increase in the pods and nodes, the amount of time it takes to scale increases exponentially. So I'm not sure whether this word exponentially is correct or polynomially is the right word, but effectively it's not linear. It's a bit beyond linear. Okay. And to address this, of course, the CA folks already recognize this. Recently, they introduced provisioning request custom resource to reduce the end-to-end scale-out latency so that you can consider a huge bunch of pods at a time and run analysis for scaling on for those pods. However, they don't have any benchmarks for this new provisioning request custom resource. And we have seen this is also a bit of an unstable feature. There have been several bug fixes over the last minor versions of the CA for provisioning requests. So if you look at 1.31, you'll see several bug tickets for provisioning requests. So there's still an unstable feature which is going through the bug adversarial process before it stabilizes. So when we tried it out ourselves, we found that for 4.5K pods and 400 nodes, the total approximate time was around 15 minutes. So this is reproducible locally. If you take varying different types of pods, especially with taints and tolerations, then you realize that CA run once loop takes a very long time in analysis. So, and this is somewhat acknowledged to an extent, and they have also made some proposals like this provisioning request, and we need to verify with benchmarks to see how improved are they fixes. Yeah. Then there are maintenance challenges involved as well. So as you know, we have our own fork of the CA in which we maintain the MCM cloud provider. And every release of the upstream tray, minor or major release, we need to rebase and adjust to breaking changes. And it takes a bit of time because you have to analyze all the changes and see whether they're applicable to you, what impacts can you have, and if so, whether the MCM needs any adjustment or any documentation, etc. So then, I mean, the second point is just a rehash of the first point. Especially, the problem was that we needed to change the core CA code. So there are several fork changes that we have made to ensure like the CA doesn't behave in a non-ideal manner with respect to the MCM. One of those examples was that fix no group size during rolling update. That causes a major headache. In fact, we are not the only guys who have commented out. I observed that other folks also commented out that piece of code. so then of course the maintenance also headache because this repository is very big. I'm not sure whether it's bigger than the Gardner core repository, but it's over 200 MB in size, the CA repository. And then sometimes if you're working even from office, the clone sort of fails quite regularly. Okay. Oh, the time we're running short of time. Actually, we're already out of time. Ouch. So we only covered the challenges and issues section of the CA. Then we have to explain what is the way forward. What do we propose? What is our recommender? And how we made a POC for a recommender. I don't think we can cover it in this slot.
We have half an hour, so we either open it up for questions now or we go ahead. What do you suggest?
I think we need definitely, or you should definitely spend 5 more minutes on what you are proposing. I mean, the key cornerstone is running the scheduler, having an independent recommender.
Yes. Okay, so maybe we can, you can, if I have already read this alternatives that we have evaluated, then probably we can directly go to what we tried as part of a POC that we did last year. The intent of the POC was multifold actually, and one of the main things that we wanted to prove is whether we can actually make better recommendations as compared to CA. And as Tarun also highlighted earlier on, that one of the major criteria was there was a lot of difference between the cube scheduler decisions and cluster autoscaler decisions. So when we did some brainstorming along with Vedran, then we found out that why not just run the cube scheduler ourselves, and the ones and then use that cube scheduler as a part of the virtual cluster that based on which the recommendations will be generated off. So which means that we create a virtual cluster which has the cube scheduler as is running, the real cube scheduler. It's running either in process or it's running as part of some, a container in a pod. It doesn't matter. It's just running in process, and it takes these, it applies, or it does the scheduling based on the workload that we simulate in our virtual environment. So if you see cluster autoscaler code, they actually have a virtual environment created. So they do a lot of in-house, they have a lot of in-house data structures for pods, nodes, and everything else. So they do that already, but what they do not do is they do not use the cube scheduler as is. That's number one. Second one was the problem with the autoscaler was that it only focuses on maxing out one node group at a time. And that also we wanted to address so as to have a good balance. And as soon as we implement these two, we saw that we can actually address majority of the shortcomings that we have actually highlighted above. So what in the POC, what we did was, obviously this is POC, so we just simply used, we created an embedded virtual plane, which comprises of the ENV test, which ENV test and cube scheduler. And in the real productive environment, we will not have HCD, we will not have QAPS server. We'll make it ultra fast by having in-memory minimalistic QAPS server, which is only required by cube scheduler, and run cube scheduler as is in memory. And then we clearly segregate between who makes a recommendation and who applies the recommendation, which means that the purpose of a recommendation engine or recommendation service or scaling recommender, whichever name we call it, the name is not final. Its purpose is to look at the as-is cluster state, simulate the as a cluster state and run the scheduler on this as a cluster state to see what is the best recommendation for the node. Can it actually schedule something? If yes, what are the nodes across all the different node types and zones that are instance types and zones that are available? And how do you best distribute this across different zones? This and then when you generate this recommendation, then this recommendation can then be consumed by another actor, which does not make any recommendation, but only can accept or reject this recommendation. What we did not do is, because we want to keep the scope of this POC limited, we did not, so there were some limitations that we introduced because of lack of time, and that was scale. We disabled scale-ins, there were only scale-outs, and we did not have the feedback loop that is required in order to tell the scaling recommender service that, hey, look, you are trying to recommend to scale out this particular node group, but there are resource exhaustion problems. And this feedback needs to go back in, and then scaling recommender needs to readjust these recommendations. And this we obviously did not do, but this will definitely be done as part of the productization of this solution.
Now, if someone is wondering, how did we just spend another minute on this? So effectively, we have a virtual cluster. So it has the Cube API server, the Cube scheduler, in-memory HCD. This could be simplified even further, but we just took the as-is components and we deploy the workload, the unscheduled pods and the existing pods onto the virtual cluster. Then we simulate scaling of all the node groups, okay, and see which guys got the best score. So, I mean, I'll go over that as well. So we go by price instead of wastage alone. We also go by price. So we see which has got the least price, and then we end up giving a plan, a recommendation for the final scale up. So that's how this works. So the advantage is that we use the real cube scheduler. We don't try to, circumvent this. We take the recommendations of the real cube scheduler. So you have a good degree of confidence that once the scale up is executed in the real world, the pods will be assigned to those scaled up nodes as expected and as was determined in the simulation. So the divergences in the CA, which are not there in the scaling recommender.
Second of all, we improved our scoring algorithm, and now we do not treat CPU and memory equally, but we analyzed all the data across at least 3 providers, GCP, AWS, and Azure, and then we found out we took a simplified approach because it was POC, but we did still found out a conservative ratio which we can use to determine the relative cost between CPU and memory. Obviously, some factors are not incorporated, and that is something because we wanted to keep it simple. And because of this as well, the choices of node groups that it picked up actually already differed. And we can improve on this node scoring by taking into consideration generational aspects of CPU and other aspects as well. But this is something that we wanted to do as part of productization, not as part of the POC.
And we comfortably bet the CA's default least waste expander, at least. We matched and exceeded it in nearly all circumstances. But however, most customers, big customers don't have confidence in the least waste expander. They usually use the priority expander. And in those cases where the customers painfully configured node group priority, we matched the CA recommendation.
In one case, we also betted because there were soft constraints not being honored by CA, but since we use kubescheduler, soft constraints are automatically intrinsically handled. And therefore, in that particular case, we actually picked up a much better node, which is also cheaper and also what the workload wanted in the first place. However, there are some three. Yeah, go ahead.
I guess we should open the round for questions. It's almost 20 minutes before we are on the top of the hour.
Okay, just two more points, maybe 30 seconds more, and because these are important points. We wanted to have a capability to actually plug and play kube schedulers, and that is important because I'm working on another project which actually works on providing support for gang scheduled workloads. And there we are drastically changing and introducing different stages of this kube scheduler. And we wanted capabilities to actually plug and play kube schedulers as so either default or custom. And that is one thing. And also there was a topic of having flexible workable configurations where you can have one instance, multiple instance type and multiple zone combination, which we do not support at this point of time. Vidran had floated a proposal, but with the current CA, there will be a combinatorial explosion of node groups. And this we also wanted to address. So now we open up for questions.
Thank you. Thank you for the presentation. I mean, I can start with the main, or for me, the most interesting question is how many of the issues that you found can be realistically contributed upstream? Will they even be accepted? How fearful are the people to touch working code? The other one would be which of these issues are fundamental in nature? So, for example, CA running the filter, not the scoring, probably tied to that it only looks at one node group at a time. And these are things that I not realistically think will ever be changed. This is too large a change. I mean, that would be one question from my side. I mean, we talked already about it because I read the proposal before that and already categorized it into two buckets. But yeah, I don't know about the others. Do you want to raise your voice?
I can only second what you just said. For me, it also splits into these categories. I mean, pretty much seems like we need to take action here. I think that's clear from the motivation. But it's not clear for me yet whether we can step up to what seems to be an unmaintained or abandoned cluster autoscaler, or whether we should directly go for building our own solution. I mean, I still see value in trying to use community-supported components, as also written in the document. Cluster autoscaler is one of the supported mechanisms by the community. So I have a strong preference to try try to stick to one of the community supported mechanisms. But yeah, if there are so many fundamental issues, then it might not be an option.
Yeah, as Vedran pointed out, that filter plugins, CA only looking at one face of the scheduler is a fundamental design issue, and it'll not be changed. And we have a word on it from one of the CA maintainers also, I believe, Vada Sambar he's called. And so he's written an article on that also. So that will not change. And then CA as an advisor as opposed to an executor, that will also not change. That has also been confirmed by the core team, the core committee team. So these two fundamental things won't change. What
Then
also
there
is unlikely to change is all that go routine logic, which where you end up having parallel loops of the CA. It seems they're now depending on that, I would say, non-ideal design characteristic as a core mechanic now for implementing the provisioning request feature. So I have a feeling that also won't change, but we can get a confirmation on that offline.
What will also not change is they doing the scale out and giving it higher priority as compared to scale-ins. It works for multiple stakeholders, but for stakeholders who are using very expensive machines or machines which are not really available all the time, they have massive problems with these kind of design decisions. And it is also not really configurable. So that is something that is not going to change because it's a part of the very, very core part of this, the logic, the reconciliation loop.
And the fact that this taking one node group at a time, because the node group is coupled with a zone. So
that's a unit of scale, actually.
Yeah, that's a unit of scale. So that won't change either. So I have a feeling that was a design mistake, actually. I don't see why they did that. I tried to look up, see why they did that, but I could not find out why. So it seems like a design mistake to me.
But there are other points that we can contribute. But if we weight those contributions that we can make in those areas versus the others, and it was quite skewed. And even if we make those contributions, they are not of such a great value as compared to others that we have just talked about. So from our perspective,
could you maybe explain? So if you say this, many things won't change, for example, using the scoring plugins of the scheduler and so on. So this is something that you propose here. And can you maybe explain why they don't want to change it, given that it seems to have a lot of benefits here? So why are they reluctant to change it?
They cannot if they only look at one node group is the main problem. So there is no point in scoring because they have fundamentally built the cluster autoscaler to look only at one node group at a time. So scoring would not help because virtually there is only one new node that has not yet new pods kind of in the simulation. And the scoring has no choice between multiple nodes. It's actually only one node or many nodes in this very node group. So the scheduler will schedule the pod to exactly this node. And that's the problem. Would they look at multiple node groups at the same time? Then the scoring makes sense. And then it would see, okay, wait a minute, I should rather go into this node group than into that node group. But it looks only at one node group. So this is a fundamental issue.
Why is that? Isn't that something that can be changed, or is this simply unchangeable?
Let's ask
theoretically,
the
it can be changed, but it will require major refactoring. It's not straightforward.
Mm-hmm.
I think there we are at the point where it's completely unrealistic. Throw it away, do it new is probably the only thing. If you want to overcome that. So
I have another question kind of related. I'm not so close to the cluster autoscaler community, so I don't know if that's the case, but you mentioned that one of the flaws of cluster autoscaler is basically that we have basically recommendation creation and execution put together. You are here now proposing to do a recommendation engine kind of. Do you see that as something that could potentially at a later point in time also be integrated into cluster autoscaler or Carpenter, so that we kind of get the community later on again? Or do you see that kind of a breaking change where we decide either community or we do it on our own?
So let me tell you the grand plan. The grand plan when we started this is to actually make it into a community project. And the reason is that we also see cluster API also struggling with the same set of problems that we struggled with. Because if you look at cluster API, the machine management part of it is actually quite similar. And the way we operate is also quite similar.
To the point of raising the same issues, the same issues.
So what the plan is to actually make it into a recommender, which is can become a community project of its own and can be plugged into anyone who wants to then apply that recommendation. Cluster API can then be one of the consumers.
If you look at the scope of this recommender, it doesn't have any external dependencies apart from the core Kubernetes control plane, So Kubernetes core is the only real dependency of this scaling recommender or scaling advisor. So it does not have any Gartner dependency. As long as one can define a abstract worker pool with zones, with metadata, and then one can have the workload defined, then this will tell you which of these worker pools need to be scaled up with respect to this workload, and it'll offer the scaling plan, which can be consumed as a resource. So, and this can be put in anywhere. So it can, whether a carpenter can consume it, anybody can consume it. So it's not something that is coupled to Gartner or to any third-party dependency as such. It's basically just core Kubernetes. That's all.
It's also not really going to be coupled with MCM. Let's put it this way.
Yeah, it's independent of MCM as well.
Yeah.
Marco?
Yeah, so one of the main risks creating...
Marco, we can't hear you, sorry.
Oh, you can't? Why not?
Wrong mic selected, I guess.
Ugh, what's happening? Oh, sorry about this. Let me change.
Maybe to fill the gap in the time, a question to the cluster API folks, since you already mentioned that, and they have similar issues, which makes sense given that the concept is quite similar. Do you know what is their take on this? So do they have any plans to improve something, or
no?
Why don't they act?
I don't know. To be honest, they managed to get their provider implementation in tree because they're a big player. But other than that, I do not know if they have any plans to contribute in this space I don't know. We don't know that.
Okay.
Maybe we can touch base with them if that is something that is required.
I mean, several of the issues raised are also in lifecycle roadmap, so it's not as if they are getting some, first-class support or something like that. So.
Okay, maybe next try.
Yeah.
Can you hear me?
Yes.
Yes, we can.
Awesome. Okay. So yeah, I wanted to say that one of the main risks I'm seeing for implementing things yourself that the community has some solution already for is that this will take time, right? And during that time, the community-based solution will continue to evolve. They will add new things. For example, in the recent past, lots of work in the cluster autoscaler has happened in the space of dynamic resource allocation. Yeah, so Kubernetes is introducing this concept very similar to volumes and extending it to other devices as well, for example, GPUs. So you have claims and you have resources, and pods can refer to those claims and so on. And all of this needs to be understood by your cluster autoscaler, right? It needs to understand, okay, for this resource to be available, I need to provision a node of this type because it's only in this node group available, and so on and so on.
That's the advantage, right? That's the prime motivator. We don't have to put in all that work. We already have a kube scheduler that does this job for us. So this is one of the, this is more than all these issues. The prime motivators, nobody's really thought of using the kube scheduler as is on a virtual cluster to determine the job of what's scaling to do. So that's a major differentiator. So however far the community-based projects go, they have a fundamental design. They have a limitation where they try to re-implement the kube scheduler within themselves. We say we don't want to do all that work. So.
Yeah, one additional point is that if you're talking about provisioning request, and one of the goals of provisioning request actually is to handle what you just said. We had a look at a provisioning request, and we do not want to use it because it doesn't serve the purpose. It is far away from what we are, I'm doing with in another project to actually deal with this exact problem. We are also in touch with the lead of DRA, which is Kevin Clues, and he also doesn't like it. And we don't know why they created this API in the first place. Second, they depend upon pod group. Pod group is something which is defined as an API in co-scheduling. That is a minimalistic API that doesn't serve any purpose as far as the GPU workloads are concerned. So you are right that the community will move in the direction, but the direction in which they are currently moving is not the direction that we want.
There's also the fact that they are trying to duplicate everything that the kube scheduler does. They're one step behind the kube scheduler. Several steps, actually, not just one step. So this is like a shortcut. The scaling recommender, I would say, is a shortcut. Why do all this work by yourself when you can leverage Kubernetes control plane to do the work for you? So,
but the risk is right. The risk is right that you highlighted.
3 more questions. So Johannes.
Okay, maybe building on what Marco asked, basically. I mean, from my point of view, what Marco was saying, we have efforts in the community, and we would have efforts on our side building the recommender. Now, you make it sound like because we use the kube scheduler, we almost have no effort because kube scheduler already has the implementation. Can you maybe share a little bit what you think the effort for building and productizing the recommender would be? I mean, are we talking now about a 5-year project, or are we talking about maybe 2 people working on it 2 months?
So no. 2 months definitely it's not going to be. It's going to be more. It's going to be more than a year. It's not going to be 5 years.
Okay.
It's going to be at least 1 to 2 years project, no doubt about it. It's not a simple effort to invest in.
That also takes into account compatibility with Gartner clusters as well. So it's not just that we are developing this in isolation, independent of Gartner, because we have to have a path where we have plug and play with Gartner clusters. So as well. So anybody who using Gartner Issue cluster can choose to leverage this scaling recommender as opposed to the CA, see whether they like the behavior or not, play around with it, switch back to the CA, or use this scaling recommender. So we have to do that work as well. It's not just a component in isolation as such. It has to play well with Gartner and the MCM. So this involves the integration work as well. So that estimate.
Okay, and that means that basically after 1 to 2 years, we have full feature parity to the existing solution, right?
Full feature parity with respect to what the customers are using and what we expose.
Yeah. Right.
Yes.
Okay.
So my question,
I mean, you don't have to. We're not going to follow a waterfall model where you'll only see something after 1 to 2 years. You can definitely play around with it far sooner than that. So, for example, if somebody wants to look at how the scaling recommender is doing for existing clusters on Factory. We can simulate a HANA cluster. We have developed the tools for that. We don't have them live right now, but we can make something like that for people who are interested. So I want to simulate prod Haas and see what are the scaling decisions offered by the recommender. So you can probably just spin up a virtual cluster, see this is what the node group scaling looks like, this for this workload. So you can have a scenario done that way. So we will try to make this not in a waterfall model, but we will have increments, demoable increments, which can show these scaling decisions for the real world data used by our stakeholders, for the real world workload used by our stakeholders. And we can give it in a manner so that anybody in Gartner can play with it. So we have those simulation components mostly developed. We can put it up somewhere, and then when we are developing the increments, we will allow folks to experiment with it and give feedback. It's not like only after 1.5 years or 2 years you'll see this rolled out.
Thanks. Tim?
My question is about the general approach of reusing the actual kube scheduler, which basically sounds like good idea in the first place, but the approach of running a virtual cluster seems pretty heavy to me. So I'm wondering whether there has been a discussion around this concept of reusing the actual scheduler, like probably also with some form of API, like asking Kube Scheduler, hey, where would you schedule this pod? Probably also, what if there would be an additional node, so some simulation parameters. Was there some consideration around this topic as well?
So you are
Yes,
asking to contribute upstream to the scheduler. Did I get that right?
Yeah, it probably would require something like this. Yeah.
So one thing is that we thought whether we can, instead of having another scheduler run, can we actually have can we reuse the same scheduler? But then this also puts a lot of load on the existing scheduler, and then it causes latencies and other delays that might happen when it actually tries to schedule the real workload. So
but isn't there another fundamental problem? I mean, the scheduler is similarly naive, like cluster-autoscaler, vertical pod autoscaler. They all look, in the case of scheduler, only at one pod.
Yes.
And cluster-autoscaler is looking at one node group. So it is of no help to ask the scheduler, hey, for the next pod, give me please the node, because you might have, I don't know, thousands of pods that need scheduling. So this is also the reason why cluster-autoscaler went the way they went. And I doubt this can be changed. That is as unrealistic to change that in Kube Scheduler as changing a node group behavior in cluster-autoscaler.
Second thing that you raised is it's heavy. Yes, absolutely. In the POC, because we used actual HCD and an actual QAPS server, it became heavy, no doubt about it. But that is not our goal. The goal is to completely remove HCD. If you look at the cluster-autoscaler today, they also have a lot of in-memory data structures that are actually doing and storing what the HCD would actually store. If you want to simulate this or the as-is, or if you want to record the as-is cluster state with respect to nodes and pods, for example. We wanted to develop something in memory and replace the Kube API server and the HCD completely. Not have them at all. Just have the Kube scheduler. And whatever API is required from the Kube API server, implemented minimally. We also have a prototype of that as well ready. We have to test it out.
I mean, you don't even need a separate network service as well. You can override the HTTP round tripper and go and keep it in memory. So the Kube scheduler can issue requests, and if you override the round tripper, you can have it in memory. I mean, that is if you just want it as a single process, but keeping it as different processes is also fine, actually, as long as the API server simulator is minimal, only satisfies the API necessary for the Kube scheduler to function. That's good enough, actually. So you don't require a full-blown API server and HCD. You only require the minimal surface area to satisfy the Kube scheduler.
Thanks. Raphael?
Yeah, last question, maybe because we're already out of time. Did you present this already to the autoscaling SIG maybe, or did you get some feedback from them? Because it would be interested, since you said this is nothing directly related to Gartner, just a general scaling recommender. So if we build this, can we maybe integrate it there eventually and get some more community involvement?
This is a good idea. We can actually do that. We have not done it yet.
We'll have to have some math figures also inside this, because that will be a much harsher audience. Okay. So...
Sure.
Yeah, probably not
Okay.
so harsh, right? I mean, I think the number, like, at least to me, the most interesting question is, hey, we think this could be way much better by running like a real cube scheduler. Do you know of any reason why this wouldn't work, even for like large clusters and so on, right? Because if people really find good reasons why this wouldn't work, couldn't work, whatever, like maybe they tried it, I don't know. This would be one of the main points I would be interested in getting feedback from the community, right?
Yes.
I've no idea, no experience, like how complicated things get if you allow for like simultaneous downscaling of one group and then need to scale up the other group. Like how many scenarios do you need to run there and so on. But at least one of the main asks for feedback would be, at least in my opinion, for this point. Maybe there's other like really big points where you think we should probe in this community meeting for, but I think that's a very good point.
Yeah. This is a good feedback. We take it back and probably approach them and ask for a slot.
Awesome. Then we are already 3 minutes over time. Thank you very much, everybody, for contributing with your questions, for presenting in the first place. Raphael already asked, so we will also upload, or he will upload it to the YouTube channel. Thank you, and yeah, see you in the time. Bye-bye.
Thank you.
Bye-bye.
Bye.
What's
Bye.
the next step? Do we already have a slot for the decision meeting as documented on the website?
No, we don't. But I will stop now the recording, and